Did that get you in okay? Yeah. Okay. I should have clarified on that.
Yeah. We could start with admissions and you know, admissions and graduation. That would be a good first step.
Did you look at it?
Well, it's actually whether we're
Well, let's
I like that one.
Yeah, you could have eight. Yeah, that's it. So wildly successful in the class. We have 40 labs. All of a sudden, we're deciding right now whether or not.
Well, actually, it's more. I would have gotten that.
We have 40 days. So we already are at 64. Registered. We got stuff watching this.
Because I have one.
Well, we got.
I'll show you.
The guys, yeah. So they make baby socks. Monster. Yeah, full socks. So they got it. Anyway, they worked with that company and got access to their data and were able to do some things to predict yeah. So it's like a little battery. Well, it's just a little Bluetooth monitor that sits in the bottom of the sauce. It's got a little battery on it. And so that's it's up to your iPhone. You know, so it's very basically. But all that data, they pull back in and they can do analysis on it. And they got to say,
Did you get it okay? We're all good? Yeah. Were you able to get it? Got power? Adequate carbs? Yeah, we figured rather than doing a scramble beforehand, making sure that we had some breakfast ready.
And
You guys haven't never been here before. Fantastic. Want to do a walk around 50 years. So do you run this? No, I'm a tenant. I do about 8 or 9 events on a monthly basis as well. I have co-working space in a small community, so we do more opportunity hubs. We're stood up now in Price and Richmond.
You guys are going to live there?
one search was working.
We're live there. We're going to have Fernando and Delta come in within about 6 weeks. So I'll be looking at the lab. I'll actually share the.
Yeah, well, because we're talking about all that stuff.
Yeah, I actually want you to come on the bus tour on the summer solstice. On the longest day of the year, we're going to do a bus tour day. So
I've been seeing those pictures that you made down there already. So I didn't know you were actually.
yeah, we're up and going.
So what are they into?
Education, entrepreneurship, and employment. Providing through a gigabit of the connectivity and opportunity to have a place like this, a small town where we can pair people that have a propensity to want to code, like Sean Duncan with the code camps for JavaScript and Iron Yard.
And the fun one,
Start doing that virtual boot
yes,
camps, locations,
I want to keep on going.
tied into like the custom fit money, so employers can get like 40% subsidy for any training. 27 forms of curriculum from 5 universities were tapped into for Local Go Digital.
The whole family.
Texas State College, SU group that has Tech Up, going to be opening the Tech Up Easter. So I get some of the folks that are being well needed, we know they're just going to get micro data centers, so we can utilize slicing of the internet, like stuff like that. Because like our center in Richfield is the lot, so we've got all these empty racks, why not wafers? And basically you have all of the traffic that finds out through that region, kind of give stuff like second law. It's kind of cool because we make a little bit of money there. Hopefully, so yeah, it's a good service. We're things like best of stepchild, so there's really smart.
They were able to,
So there are budgeting for a lot of long-term education, and curriculum, and infrastructure. Yeah, the rest of the infrastructure. Yeah, it's all. It's yeah, it's been a long
yeah, so they didn't get that part done, right? Things that don't exist anymore, right? Yeah.
Where's the restaurant?
So,
there's one on the far right, stay on this side. If you look towards the elevator, you hear that. There's one right there. Okay, thank you.
yeah, so really interesting. And the only cover is technically England and a little bit here.
So that's why one guy, other hacks actually. I
literally none. That's what the world's gonna put on somebody. So it's the
and so I actually I started listening to learning JavaScript, and I think it started as 1%.
well,
And I'm going to people sign up. And so at this point, we've got 600 people.
but it's pretty stark when you pull up a map of the world and say, let's go back to 1770, 1700s and say, okay, where's all the records?
Cycle.
And
So,
right
now, the other side.
that's the only records we have.
So it's funny, this triangle sign, it's just, hey, I was like, you're sure. No, it's not, but a good friend of the founders. Yes. Yeah, that's for the that's way more. I still sort of take it. So I love I'm sure that you put a little mess, it's still very small. Yeah. But I like it right now. I'm going places.
Well, the other thing that I think would be great is, so we have the family search that all the index of what do you guys there, Jason?
I work
I think we start small and we say the family search data. And we continue that well, we could do our U data. So if you can start looking into it, if you try to do that,
I'm just going to the end of the summer.
Oh, we're live. Everyone do
I'm actually working on some Asper Crunch programs and look up on my desktop. There's such a need for that.
yeah.
Just say, yeah. So if there's any concern, you
Yeah, just for the
yeah, but the thing about it is,
and we,
the institution is not the analyze it. And so we just have to have this umbrella.
Pretty watch. Well, it's very linear. Here versus
And then they compare. So it's yeah.
These are exciting.
You don't want to stick with them.
We're certainly going to buy out. Next time.
I know.
You'll commit to like give us kind of over a period of time. We basically say long statement called the bus congestion. And
Well, one of the things I'm going to do probably is,
do you know anyone that I could?
reply to the,
I'd like to look at the dialogue.
yeah.
He's actually.
Oh,
He's working with Pham. He's got a company. Just check out front analytics. Where the fun's at. There's probably kind of area.
get those,
But Fernando, he's looking for mentees.
So then we also have.
Yeah, I'm very motivated. I think
that's why the people in Brand, they have some Raspberry Pis. All scan.
So, well, I'll be monitoring the live feed from Berkeley. They told me originally it was going to be starting at 8 o'clock Pacific time, but apparently it's been pushed a little bit. So I'd say network, enjoy the bagels, have some coffee and everything else. We know it's going to be a long haul anyhow. If you need anything, my name's Joel. I'll be what I can. And, sorry for interrupting. Go back to network. Appreciate it.
Hey, good, how are you? We're doing well, how are you doing? Yeah. What you doing? Where are you at?
I was in South Room,
So you use
and
I use-
I mostly did homeless.
Google and Bing, zero recommendations are.
Yep.
It shows you the real time.
Yeah.
Yeah. So the house one I use when it's lost. Yeah, this one should see.
I really used to do it. Yeah.
I teach so I did short one, another one is the ones I use. And I have over like a hard line. Yeah. So I go grab another
So you guys have. Trying to do something that find out. We have
Yeah, so it's funny because this last calendar year.
where the stuff
I have my official works on next year, and I'm going to site now. Parsing and which language as
teams are kind of
Yeah.
I'm looking at.
No, I'm actually gonna bring a charging cable. To see how long I can last.
I'm sure we got an extra charging cable here for now.
Oh, okay.
Well, you have to keep Keep on going. Keep us in mind. We got this big data class. And as part of that, and so we split them up into groups. We teach them data mining, data science, the first semester, and they start working on the data. The second semester, all projects. And they're always looking for people to sponsor projects and work with.
Hey, how are you? Good. Make yourself comfortable. We've got coffee, bagels, and stuff like that.
So
Nice to meet you.
Whole semester plus.
No, not at all. Feel free.
Some of them have turned out pretty good. So.
And if I need to get a second power strip, I can. But I think you should be able to plug it there too.
Some of them, we're
Good. All right.
This semester, this time around, we're gonna try and get them hooked up on, on some of the grants that Amazon allows, and use the Amazon data sets as well. So like I was telling Brad about the Google Line Grant database and the Google Works database, and all those scan documents that they, OCR things, right? So one semester, found out when words disappeared from books. They found words that were here and then all of a sudden they disappeared, and never found them here. That was kind of fun.
I'm sure I can think of some flash interested.
Yeah, and these guys are getting trained in, data mining principles, like data mining algorithms, and large data systems. So, we're working on how to do computing using you think of something, shoot me an email or Christoph, either one of us. And so we work together on the class, and then additions that are coming in too, so it's that is the process. So we're much better statistically student computer science. So.
So right now we're just kind of doing it.
Messed with it. I know about it. I haven't messed with it. I haven't.
We try to do it.
It looks interesting.
Yeah. Think about genetics and stuff.
Yeah, I know some people are using it for data mining and stuff, but mostly stuff that I read about and stuff I see is scholar based. It's hard now.
But we're like tracking where you
Java, Python, rather see it away from
the data. We're starting one
where all all tools right now seem to be Java based, but have the ability to be accessed. Anything from the VM. There's a couple of people that are playing with it, and
I'm
kind of C++. Most people are staying on Java because most of the pages
we're still not kind of looking at
Yeah, so I, do a couple of track.
And that's what the photo.
Well, and you're.
But it's
Yeah, I haven't seen people do it in the whole lot. Wise, yeah.
That's an all the kids, right? It's hard to find.
It's a matter of interfacing with the system.
Oh, that's excellent.
Yeah.
During this.
Well, it's a matter of interfacing with so it's a matter of integrating interfaces.
and my colleagues
Well, keep your ears, keep your thoughts open, making something that data mining students can do. Oh, yeah, well, like I said, we don't have our opening meeting for the students, project ideas to students. We generally about, second week, third week, so we try to have a very opening meeting where we generally meet with the sponsors. Actually, that's when we meet with sponsors. Christoph and I meet with the sponsors, and that can happen at the conference too. We did that last week. We just meet with everybody, make sure we know what's going on, and then like we have a big meeting. With all the students and kick off the meeting and all the project, all the sponsors and the project ideas and students and network and interact with them and try to come through like what's going on you got and then they all submit us their top 5 choices and then we kind of push it over. Yeah, yeah, so if you keep in touch with us, we'll include you on that mail out when it goes. So that'll probably be happening here. Try to do that kind of stuff.
Right now.
In July. So, sending out other requests. So you guys can think about it for a while, you know. The thing is, we're hoping to get Brad to do some analysis with stuff like that. We got the whole family search database from last year and some stuff.
As the classroom usually have a parallel processing or
We do both. So a lot of times what we'll do, it's a good.
Say how many would be the pictures of the
Start off teaching how to do some systems.
I'm gonna CC you. How are you?
We have a little problems.
And congratulate him on his award for innovation awards. He was from a device standpoint. He was one of the finalists. Innovation. He's the nicest guy. Super smart. And And he's got a vision for the device as well as the education that comes along.
Many of the operators are-
Yeah, you feel like that.
Can't do,
It's a desktop.
So,
Yep, and then it has just the desktop. Yep, and then it's Hub Desk 1776.
good mix. And this is-
Yep, awesome, thank you.
So he'll be driving Madison and, so we can bring it on.
I think he had it 2 hours set up there. I can't remember that. That's very
And then, like I said, we put statistics on each of the teams. We all expect them to have this computer science background.
I just, and I have a son, I have a friend who lives at this place.
That's my, the idea is that you have three computer science and trying to keep the groups of four. You know, every other week.
So.
Anyway, this guy's going to my court.
other companies.
a lot of experience with product management, and I knew a lot about healthcare, and I had built data warehouses for hospitals, and I knew a lot about healthcare data. It helped me a lot in my personal life. So now I was kind of product managing all of our hospitals. We've been to 5 different hospitals around the country. So for those of you who are familiar with electronic health records in the state of healthcare in this country, you know how complicated that might be. And so I switched from being on the provider side for all these services I've been trying to build for people for the last 12 years. I honestly have days where I feel like a personal failure for not leaving the system in a better state for people like me to consume as someone who has built some of these systems. Open the system with her as a leukemia patient, all these skill sets I've developed in a professional life back to my personal life. And at the time I was working at Google, took a little bit of break in healthcare and worked on Google in Google search, indexing, storing the internet. We try to figure out better ways to store the internet to more efficiently give you your search results. So that was like the state of my life in 2013. I got a call from Mike Dickerson talking about this thing inside the White House called the U.S. Signal Service. Mike said, I need someone who knows healthcare and data. And at that point, I remember thinking, where I can merge the data, the health, the public service, already that opportunity. But this really is maybe another great opportunity to merge everything I've ever built and learned into a new role. We were about 10 people at that time, and it exactly was that, but even more. So I had never considered working for the federal government. For me, public service was nonprofits, working on these other things, not. And it turns out this is the best public service thing that I can possibly do. So as time went on, I started, it was the electronic health record system, look at interoperability between the Department of Defense and the VA, because when our active military leave the Veterans Affairs, I'm dubious as to what gets from to the VA and what kind of medical records they get. But then other things came up. The Precision Medicine Initiative was launched in January 2015, and then the Cancer Moonshot was later again. So all these opportunities kept coming up to apply a lot of what all that just because, not because, oh yay, I found my dream position, but because it's a federal government, there's 25, 26 different agencies, many of your backgrounds can also apply to so much of what we do here in the government. So I'll go into just really briefly, the 4 of the different projects that you're probably possibly very intimately familiar with some of this as well. And there are many more projects than I've listed. So Jennifer briefly talked about this and actually went into a lot of detail. So incredibly exciting about this is that it was launched last September. There were over 1 million users. And the last part, 7 tools were launched using the data API, including one in Spanish. As we gave the president and other folks this thing that they can use for fancy talking points and show all those things that Jennifer listed earlier, where you can really see you go and what really is the best ranking versus if you looked up school rankings today on Google, you'll get a whole list of like Forbes, US News, different third-party sites. So this is meant to be a very reliable place to go. So this is like a nice, cool, flashy site. But the most exciting thing off of open data. So anyone, if you don't like the way this looks, awesome, go make your own. You can pull the data and communities across the US are already doing so. They're building. I have a friend who's doing Teach for America actually down in Atlanta at some of the poorest schools in Atlanta where kids really don't understand where to go. And just to build visualizations that are helpful for Atlanta public schools specifically. So that for me is one of the most exciting things about something like this, and it was built within a few months, 10 years, which if you work for a contractor or done something that you know what that means. The other very exciting thing that you may have heard of in the last few months, the last 6 months or so, It's a police data initiative. This is something that is unfortunately in the news a lot, departments. And what we have is, initially it started out with just 21 different police departments committed and committing their data. And then within a few months, it became 26. And within a few months after that, it became 53 different police departments. That these police departments released over 100 different data sets about all the data that goes on within the police departments across this country, and also how to understand early warning signs and how to better train the police officers if they need them. This is another, I think collaboration is a big theme. This is another example of collaboration across the board. The federal government, we can just do so much as the federal government, right? We can say, hurrah, hooray, go do this, but there's a lot we can't do. Governments, Code for America is involved, a lot of local data scientists that volunteer their time, and each jurisdiction is a little bit. And so I said, I'm really on the higher side. Always been the largest size of the last 12 years. And then the last one I'll talk about is initiative and the cancer moonshot.
Okay, that was grandma's.
I haven't touched anything. This is across several agencies, Faire, National Institute of Health, etc., to bring more targeted care to more Americans. An example that I think about a lot is when I'm sitting in the Cancer Infusion Center at Stanford. Hopefully you never have to go, but it's a place where blood transfusions if you have to, and it's pretty open. There's no secret barriers. So what I'll do is I'm just going to eavesdrop a lot on the conversations around me, just to hear research, just to hear what's going on. And you'll have two people maybe with the same type of leukemia, maybe Pham, Caucasian, white male, and one person may be a Asian female, and they both have acute lymphoblastic leukemia, and they both will get vincristine for their chemo. A doctor might say, cross fingers, that'll work this time. That we don't know exactly why a medication may or may not work for one person, or may work for one person, not work for the other, when we may already have that data available. It's just not in a way where we can really truly understand it. Another example, in like a less dire case, is if you just think of you and I taking Tylenol, we might buy birth control for women. I think many experiences are if you go to the doctor, they'll just keep trying different ones until they find one that works. So the reason why we shouldn't know based on our information. So this idea of combining your genomic data, your diet, your lifestyle, all your electronic health data, finding out what works for you. That's on the White House website for precision medicine. So a couple of things that are going on across agencies has put out a call to get 1 million Americans to sign up to donate their data. So that's kind of what the Veterans Affairs has already been doing with 400,000 vets. We have 400,000 vets, including the secretary, who have donated their blood samples for genomic research. And the VA has the largest electronic health record system. Electronic health record system. A lot of work going on to figure out how to combine all that to do more meaningful research. And the DoD is also now partnering with the Department of the VA to do research in that area as well. So there's a bit of work around that area. I think there are probably folks in this room who are doing a lot of work with that as well. And that has led to the cancer moonshot. It's this idea. Data is a huge part of it. It's also a lot of research, a lot thinking of how we can use, thinking of how we can do cancer detection, immunotherapy. There's the Vice President's Exceptional Opportunities in Cancer Research Fund. Still figuring out what all that means. It's a new initiative that was launched earlier this year. There's a lot of work, a lot of ways you all can influence. The VP just announced a Medium channel yesterday where people can, so you can crowdsource, people can contribute their cancer stories. Very low fidelity way of getting involved. If you ever want to share a story and have it posted on that site, you can do that as well. Agencies are involved with this. One example is that a Million Veterans Program. I was talking about how there are 400,000 vets who donated genomic data. 32% of those cancer detection. So there's a little bit we can do there to get started, but as you know, with the VA, the demographic isn't as broad as maybe all of America. So that's where NIH comes in with the 1 million cohort of Americans. This year going on with the Cancer Moonshot, Precision Medicine, Department of Education, and the Police Data Initiative. And there are many ways many of you can get involved, whether it's getting some of the code off of GitHub, using the data that we have open, your knowledge and expertise via various channels that we have for feedback, for precision medicine, and the Cancer Moonshot. There's so many different ways to really use all of your data and engineering skill sets to help us. This digital service. Thank you. Jennifer and Kathy for sharing your stories and highlighting these very inspirational initiatives. And I will raise my hand and say, yes, we can do more than cross our fingers in a chemotherapy center. Yes, we can work together to bring the skills and talents of all of us in this room. And yes, hashtag open data. So thanks for that. And collaboration that both Kathy and Jennifer mentioned. We have next a lovely parade of a preview for our Collaboratory Faire. So all the folks who are presenting the posters in the session we're going to have a very fun flash mob of innovators coming up. A little preview about how they make data science a team sport. In order, this is going to be a rotating musical chair. You'll come on up, you'll speak for your 2 or 4 minutes, and you have to circle back and do it again. It's just a one-time thing. Okay. We'll have Fernando, Perez, who is a Project Jupyter fame and from Lawrence Berkeley National Laboratory and Berkeley Institute for Data Science. We'll then be followed by Sarah Stone, who is our West Bay Data Innovation Hub Deputy Director and also at the University of Washington, followed by Data Carpentry's Executive Director, Tracy Teal, and then Ariel Rogan from the University of Washington, who also serves in this spare time as a co-PI for the Hub. We have the Director of the Audio and Multimedia Lab at the International Computer Science Institute, Gerald Friedland, who will be speaking about multimedia commons. Nick Badley, who's the founder of Big Data Utah and Evolve Steam, as well as rounding out the group, Alton Alexander, who is a guild master with Big Data Utah. So come on down, folks. So we've got your slides already loaded.
Alton Alexander.
What I have here is a very schematic description of what I think is actually not a completely wrong way to think about what we often do when we work on computation and data. We play alone with algorithms. We try to run code, visualize it. At some point, we try to collaborate with someone. We end up emailing scripts back and forth. If we're going to run, if the code proves to be a good idea, we need to run it in production. Somebody has to rewrite it to run it on a large scale. Your MATLAB prototype has to be put into another language. If you're going to publish that, and hopefully your results are successful, you're going to publish it, you copy and paste a lot of figures, and then if you're going to teach, you end up making PowerPoints that are also copy-pasted from something else. And we would like to think that this should be considered a single problem. And what we've tried to do in Project Jupyter is to think that this is a continuum and that if we approach it in a unified way, we can build better computational tools to allow you to move back and forth fluidly on all these stages, and do all of it in a much more efficient, collaborative, and open way. Again, this slide, when I was a physics, finding anything to do other than work on my dissertation, and obviously writing an interactive environment for computation in Python sounds like a much better idea than analyzing my data. And so I wrote language to have a better interactive console that would give me the workflow that I still was used as a scientist, which was run my code, look at my data, pop up a plot window, and then iterate and explore how I wanted to pursue the problem. Not software engineering, but exploratory, kind of hands-on fingers at the keyboard, massaging my data and thinking about my problems. It was a terminal-based, very kind of Unix-like. Fast forward 10, 15 years of work, and everyone else other than me in our community doing the really hard work. And what we have today is a project called Jupyter, and I'll get to why in a second. Which, among other things, one of its flagship ideas is a system that we call the Jupyter Notebook, which is what you see on the screen, a system that runs through the web browser and allows you exactly the kind of thing that I was showing in the previous slide, where I can run a little bit of code and see the results, but I can also combine that with any graphical or multimedia element that I can display in a web browser, which these days is just about anything, audio, video, animations, etc. And also, very importantly, annotated text, including mathematics and rich text, so that we can get to this idea at the beginning of not only combining code and data and results and visualization, but also narrative, therefore publication, communication, social interaction, etc. The reason why the project evolved from the name like Python to what we now call Jupyter is because Python is a programming language, but what we're trying to do is build tools for science, research, and computation, and that happens in many programming languages. And so Jupyter is really the name that represents the fact that now the same original ideas apply to all programming languages. Our architecture is supported by over, meaning that the work that we do can be in any of these environments that are used in that work by data scientists in many disciplines, and the overall architecture will still support your work. One recent highlight of the kinds of things that why it's worthwhile, and for me as a physicist, this was very rewarding to see. In 1915, Einstein predicted that if two black holes were ever to collide somewhere in the deep recesses of the universe, we could see the effects of that collision as ripples in the fabric of spacetime. This was a very hard prediction to test experimentally, but recently, the LIGO collaboration, which has two very large interferometers, one in Washington, one in Louisiana, and detected this signal. And it was very gratifying for me to see that when they presented the results, the LIGO Open Data Open Science Center actually published the analysis that lets you two black holes from 2 billion light years away in the form of Jupyter notebooks, meaning that you can go to their site, download the notebooks, and play with it yourself. And we actually made that available as something called a binder, which lets you with one click execute it in the cloud without having to install anything. This is not only a project for academic research, we have lots of collaborations with industry, so this is just a very quick overview of projects from Microsoft, from Google, from Computing Analytics, from O'Reilly that use this platform for education, for data science, for machine learning in the cloud, and other things. And if you love this, please come to see me and my team at the poster in the back there. Thank you.
Hi, so I'm Sarah Stone from the eScience Institute at the University of Washington, and I'm just going to talk briefly about a program that we run called the Data Science for Social Good Summer Program. After programs you may have heard of at the University of Chicago and Georgia Tech, built upon a program that we've been running for several years called the Data Science Incubator. We ran this program for the first time in the summer of last year in 2015, and we'll be running this program again this summer. The Data Science for Social Good program is an intensive 10-week program. Together researchers and students with domain and data science expertise tackle challenging data science related projects in the urban science sphere. These projects are submitted from researchers at the University of Washington as well as from agencies across Seattle. And for more detail, you can come and see the poster at the lunch break for detail on those specific projects. But we have a pretty broad call for proposals, and we've received proposals and have worked on projects in a variety of different related topics, including housing, particularly finding housing for permanent housing for homeless families, transportation, particularly for those that are mobility impaired, social media analytics, and also issues related to public health and safety. Our teams, the data science and social good teams involve these project leads who are who provide the proposals for the projects and actually come and sit with us in our awesome data science studio 2 days a week. These teams, the teams also involve a data scientist. The Science Institute has a staff team of data scientists. These data scientists work closely as the technical lead on these projects. And we also do a broad call for students nationwide. We have 4 teams with 4 students on each team. These students are a mix of advanced undergraduates and graduate students. This past year, we received over 200 applications for 16 slots. Competitive process. Exciting because we get applicants from diverse disciplines. Disciplines you might expect, like computer science and statistics, sociology, but also disciplines like astronomy. Students that come to this program that are sort of working as their research career in these data science for social good kinds of areas, but we also have students who are just very interested in doing this kind of research as sort of a hobby over the summer. What's really unique about urban science is that it really attracts a broad sphere of people. Accessible, because many of these issues are things that we all deal with on a daily basis. When we spend time in the data science studio, they're not only working on these projects, but we provide tutorials across a wide array of topics. These are supported by programs like software carpentry. They work over this intense 10-week period, and then we have final presentations at the end of the summer. And we've been delighted to discover and had this verified by the Gates Foundation on a project that we did on permanent housing for homeless families. In 10 weeks, these students accomplished what consulting. So, and and we were surprised to have the Gates Foundation coming to us for help. And that now the tables have turned, and actually they continue to support that project, funding our data scientists and some students to continue to work on that project, including actually Aria Logan. So, if you'd like to hear more about this program, please come visit the poster this afternoon. Thank you.
Doesn't matter, I don't have slides, so it's okay. Oh, I need to press the button.
Good, Nikki B.
Anybody from Microsoft is here. I'm not really impressed with the.
It's because of the touchpad, I'm touching the wrong things. So I'm really excited to get the opportunity to speak today, and I especially appreciated Jennifer's opening remarks about data is about people, because that's something that I really believe in as well. Take the chance to talk about the role and need for training in data-driven discovery and what data carpentry is doing to help address some of these challenges. So with the emergence of new technology generating and making available data in almost all domains of research, data production is no longer the bottleneck. The missing piece is the training for researchers to turn data into knowledge. Even as universities universities are starting programs in data science, most existing researchers lack the skills needed to effectively analyze and manage their data. It's not just us who think that researchers need to know these skills. We're not coming to them and telling them they need to learn these things. It's researchers themselves that are demanding this training. Resource Bioinformatics Australia, 50% of respondents said the most useful thing this organization could do was to offer training. Said who could provide funding. One of the few times in the survey I've seen money low down on the list. And so Data Carpentry is working to fill this training gap. We develop and teach short, impactful workshops on working more effectively with data. Hands-on, and they consist of lessons in data organization, processing, analysis, and visualization. Workshops are domain specific, and that's to give people the skills that they need to work with the type of data that they have, so that after the workshop, they can more immediately apply the skills they've learned in their own work. For data analysis and visualization, currently working with ecological data, genomics data, geospatial data, and we're working on lessons for social scientists, high-performance computing, and libraries. Also, they're focused on people with little to no prior computational experience. There's actually few resources in this space, but yet it's the vast majority of researchers. So we've chosen to focus on this audience for our first set of training initiatives. Even though in our 2-day workshops, we can't teach them everything it is that they need to know, we can get the researchers started and build a foundation and the confidence for them to continue to learn more. In one of our workshops, in our ecology workshop, we teach data organization in spreadsheets, not to teach people how to use spreadsheets, but how to structure their data and organize their data to get out of spreadsheets so that they can use tools like R and Python. We teach R or Python for data analysis and visualization, and SQL for data management. So results from these workshops suggest that people are learning the skills we're teaching in the workshops, and that they feel that they can immediately apply what they learned in their own work. It's also changing their perspective on how these skills can make them work more effective and reproducible without an exposure to things like scripting or more effective data management, know sort of what they're missing. And so it really opens up the possibilities of what they can do with their data when they start to learn these skills. Finally, the most important survey question of all, would you recommend this workshop to your colleagues? 89% of respondents agree or strongly agree that they would recommend this workshop, suggesting that these are workshops that are valuable to people and worth their time. All the more impressive that because we are a volunteer community-driven effort. Are taught by volunteer instructors, and all our lessons are collaboratively and openly developed. Organization Software Carpentry run an instructor training program. We now have over 400 instructors in 6 continents. We don't have any in Antarctica, sadly. Since 2015, Data Carpentry has taught over 50 workshops to 2,000 learners. Software Carpentry has taught over 120 workshops to 40,000 learners. We also develop new lessons and work collaboratively on lesson development with organizations such as our OpenSci, Neon. And if you're interested in hosting, volunteering, becoming a partner, and helping to build local capacity at your university organization, you can visit our website, datacarpentry.org, or contact with us at the Collaboration Faire. Talking further, we'll be there today. Director Aaron Becker and our collaborators are OpenSci First Grant, and we'd love to talk more with you.
Ariel and Ken, and I'm a data scientist at the University of Washington and COPI in Western Region. And though I spend a lot of my time collaborating with researchers from a variety of different disciplines and working on projects like the Data Science for Social Good, My own research program and my own development is in developing methods and tools of data from neuroimaging, MRI data in particular. Neuroscience and neuroimaging in particular is at the cusp of a really exciting big data era. Fully funded projects are making ever larger databases of MRI data available to researchers to explore, investigate things about the brain. The numbers are starting to be really, really large. The Human Connectome Project is making available more than 1,000 different brains scanned in several different MRI modalities, together with genetic information, clinical information. It's a project called ABCD is going to make available 10,000 individual human scanned available, and the UK Biobank has recently announced that there will be 100,000 different people. So the data is growing ever larger to extract really useful information about human health from these data is becoming also much more interesting. And with that come very large challenges. And today I'm going to tell you about a community project, a broad distributed project that addresses some of the challenges that come together. That's neuroimaging in Python. So the Python programming language in recent years, Franca of scientific computing. Fernando spoke to that a little bit earlier. And neuroimaging in Python is part of a broader community called SciPy that develops open source software computing. The openness allows us to make the tools that we make available to scientists to make their science reproducible. As part of that, and the tools that we develop, the projects that we develop are also part of that. The work is very collaborative, and that makes it the projects, the software projects that we develop are not owned by a single lab. Typically, in neuroscience research, is available, or might make their tools available in a rare case, actually. But then they sort of own that. Instead, the neuroimaging in Python community is shared among researchers from many, many different groups across many different countries. We have developers working with scientists and developers, researchers in at least 12 different countries. And then that makes the work more sustainable. I'll give you two examples, and I have a whole list on the poster back there. You can come and talk to me about the different projects of projects that we work on. First one is Fusion MRI in Python. This software project focuses on Fusion MRI, which is a modality of MRI that allows us to measure connections between different parts of the brain, as demonstrated in that image over there. This one is notable also because we've been partnering with the Google Summer of Code internship program. This internship program allows students to come and work on an open source project 2 months over the summer. We had 2 students last year work on that. This year we have 4 students working on a range of projects, including projects on web development, modeling, a whole range of different things. The other project I'd like to talk about is NeLearn, which is machine learning, notable because it relies on the broader scientific computing community, in that it's very heavily based on the scikit-learn, which is a very, very popular library for machine learning. So it integrates very closely. I'd like to just mention that we're very focused on training. This is something that keeps coming up here on the stage. We're very much focused on training. One project that I'm very excited about that we're organizing up at the University of Washington eScience Institute is NeuroHack Week. This will be a week-long hackathon summer school that we're organizing. We're going to have 40 participants from all over the nation and world eScience Institute spend a week hacking together, working on group projects, learning from experts in the field about the tools that we develop and many other software tools. With an iPad, I'll be back there at poster later on. You can come and talk to me about the other projects that we have and ideas. Thank you.
The big keyword here that I want to start with is field studies. Okay, so how do you learn, like how babies learn to catch a ball? Right? So the typical example that I give is you go to IRB, you ask for permission to virtual subject, because they're small babies, then you collect about 50 to 100 videos, and some parents will not show up, sometimes will, and then the babies will collaborate or not. So it's going to be a process of about. So at the same time, Darwin used to travel. There's all these examples of field studies. At the same time, we know that about 100 hours of video is uploaded to YouTube. Right? There's a huge amount of data. The problem with that data is not accessible for us for research. It's not accessible for legal reasons, and B, it's not accessible for us for research for technical reasons, because try to search for baby catching a ball on YouTube. In fact, do that right now. I mean, after a talk, you'll find about 20 to 30 videos when in reality you should find, because of course that's one of the prime things that parents do, is like, look, the cute baby, right? So the problem is, of course, the Google only searches through. So we decided we should change that. You change, you have to have data, right? And so what we did is we went to Flickr, in fact, to Yahoo Labs, get some data, and we did this a couple of times in a row until, in reality, they got a little bit, and I can say that because unfortunately it's all restructured, so the people who work with are not there anymore. So the point is, how many videos do you want? I said all of them. Oh, that was pretty amazing. So they gave us all the Creative Commons images and all the Creative Commons videos that are on Flickr as of April, I think, 27th, 2014. So now, of course, you can't just go with a hard disk and say, okay, I put them on here, right? I think 100 terabytes, you can ask Jan, he knows better, he's supposed to do that. The point is, okay, so we then teamed up with a whole bunch of people. We teamed up with Lawrence Livermore Lab, because Lawrence Livermore Lab is a huge compute, and they help us extract features for machine learning. Look in the audio space, in visual space, in multimodal space. We teamed up with the UC Berkeley as well, because we wanted to have tools that people can actually work with those videos right away. We teamed up, and that was the biggest game. We teamed up with Amazon Web Service and say, it's a huge investment, but can you please host that data for us? And in reality, yes, they are hosting this data as part of their public data program, and access it. So the idea behind all of this is that you don't download these videos, really, because it's a huge pain, trust me. You're not Flickr. But you can do is you go and SSH into an Amazon instance, and you have tools at your disposal. You can right away work with those tools and do whatever research you want. So what data do we have? So all the videos, all the images. So we have text, geotext, timestamps, descriptions. You find on Flickr. We also have, because benchmark initiatives, including the European Media URL, the Asian Media Grand Challenge, missed as part of their tracklet is using the data now. It's like for different tasks. Annotations, of course, you need a browser tool, right? There's this Event 360 system, which we have created for actually searching videos, not just by keywords, but by geo tags and different other features we presented back there. So on the cover of Communications of the ACM in February. And what I like about that one, somebody recreated the Lincoln statue in DC, just using all the images that were geolocated from the Lincoln statue in 3D. And we have the browser, for example, from the FKI, who created tags. So you can see, okay, enter cat, please don't do that. It's a lot of these are just cat videos, of course, but you want to see which kind of text do you find just really quickly to see what kind of data is there. The thing is, resource for everybody here. If you want to do some empirical research on data, this is all either public domain or Creative Commons. and you can access it right away. Go to the website, myvideocommons.org. We create tutorials. We have all kinds of tools that we put on there that come out of different groups. For example, we have Cafe on there, a deep learning tool, just sort of a deep learning for audio specified. Yeah, so I just basically invite you to check the website out and check our poster out. And yeah, thank you.
On this thing here. So. Okay, well, so, sorry, Meredith. Okay, so my name is Nick Bagley. I've run Big Data Utah and the Utah Users Group for quite a few years now. In that space, nobody knew what big data was. Nobody knew what Hadoop was. Get a nationwide and mobile. And over the years, I've helped build teams, build communities, build many different people. And as I've done that, I've noticed that I spent most of my time focusing on people's skills and understanding what they were capable of based off of those factors. And I think most of the world looks like that. As gone on, I've started realizing that as we move into the shared economy and into shared services and into that we can start looking at people's aptitude, enjoy, and why they enjoy. But one of the things that's kind of interesting that kind of led me to understand this is to start looking at it and start building out Evolve Steam and the things that we're doing with our data science guild. Looking at income disparities on people on Kaggle. Under the top 1,000 people on Kaggle or on LinkedIn or any of the best data scientists in the world, there are huge disparities reflected by their geography or by things that maybe you would consider factors. It tends to be more about who they are and who they've been connected to and many other things that come back to their passions and their aptitude and why they're doing it. It's called the Go-Giver that talks about this principle, and it talks a little bit about how an entertainer might make millions and millions of dollars, sometimes $100, $200 million in a very, very, very short period of time. And then contrast that with many of the people in the room or that are in education, who may provide an extremely high value to a student or to an individual and may change their lives. And it seems pretty unfair that a teacher may make $25,000 a year in Utah, while an entertainer provides a few brief moments of entertainment. Well, so that book gets down to the core reason why, and it talks a little bit about how perceived value, the number of users that you have access to, is what determines your income and your revenue. And so if we can start helping people understand how to increase their perceived revenue, if we can start or perceived value, if we can help them start understanding how they can be better and better at what they do, and work with others who are not focusing so much on, rather focusing on their skills like data science, applying the number of users that they have access to. It's difficult, but sometimes working for one employer creates a glass ceiling. Our ultimate potential is from an earning perspective. And we start talking about some of the other reasons. So Daniel Pink talked about motivation, and he talked about autonomy. That's true. And he said that when we talk about money, many people are motivated by money and what it's able to help them achieve. But in the long run, what we're really motivated by is that ability to have freedom. It drives us. So something that helps us become incredibly passionate, master in our lives. So we've designed programs that now allow people to focus on what they care about across academia and industry and nonprofit organizations, and then companies, everything from consulting firms to the largest organizations. We're helping groups and people tackle what they want to accomplish. For the people who PhD and are making half of what the people in industry are making, to be able to find a path where they can live a sustainable and financially good life and career, where we can help people take the things that they're passionate about much larger scale, get into that sense of purpose and science for social good, or greatest challenge or a passion that they are interested in. So I really focus on thinking locally and then scaling globally. So I started with a lot of my passions and things that I really care about, and then started working with people locally, and now we're starting to scale that outside of just our area and starting to grow into universities where we're helping with capstone projects and with government where we're tackling large problems such as air quality and other things. We're creating conferences and competitions and many other things. A little about that. But the thing I want to say is that it's difficult to really care about what you're doing day in, day out. Focus on what is most important to you. With the community, and you're able to all work on what you want to do, we can start making a difference in our cities. The national priority challenges that we're outlining as the West Big Data Hubs. To accomplish what you need and what you want and what you're passionate about.
It's Alexander and my next colleague in Utah, and to round out the panel and to give an example of what we're doing in Utah area, starting locally and then really expanding globally. Here are some of the things that we're doing to collaborate across academics and industry, government, and nonprofits to really create open access to data, to insights, and to training. So, and chief data scientist of an analytics company where we take on projects and do consulting work. And I work with a network of well. And what we're realizing and recognizing is that when we go in and work on projects, we're finding that there's just an overwhelming desire for more and more of this technical talent, and that there's just not enough demand across all of these. And so in doing so, we've found 3 different programs that are helping foster the ecosystem and build out the training. And first is the community, first and foremost. So like in any area, we host and direct events where people can come and they can explain what they're doing, what they're working on, these workshops and these nightly events, conferences. We also are working heavily on getting a boot camp set up, similar to what we have here in San Francisco and in New York. Boot camps where in that short 10 to 12-week time period, someone who's working on projects, paid or where they can make a immediate impact, but also in a really short period of time, dive deep those skills. And the way that we're doing that is also third by working a guild model. Masters to work with apprentices, and so that they can get exposure to also work at their level and their skill set, and to really be able to drive progress in learning. So we're finding that these methods are effective for building the ecosystem, and there's no end to the amount of interest across these sectors and that we're really able to take on. I'm also excited to be a part of a startup, one that is involved in data storytelling. And so when I heard the announcement today that on June 16th, there's going to be a storytelling event in LAM. And we'll be available also to talk about these things that are happening in Utah during lunch.
Thank you so much, Collaboratory Faire participants. I don't have a walkie-talkie, so I'm trying to see if we have coffee or food back there. Can anyone tell me? Do we have coffee or food? Yes? take a break. I can't see with the lights. Is that a yes? Okay, so we can take a 7-minute break and also say hello to our graphic facilitator here, Dana, with us this morning. Thanks so much. Only 7 minutes.
Anyway. So yeah, it's really awesome. Where are you at? We have internships. We've got a handful of resources available and a way to So there's the British
So I just mean in terms of like organization, yeah. Don't worry. It's all about like writing graphic I actually gave it talk on it. I wish I had their information so yeah. I have yeah, it's one of those things. Don't use this.
I think that's running late probably. Yeah.
We've got a buffer back in.
No problem.
I started streaming back in '98 to that's
Oh.
It's come a long way since then. We had to have basically a rack of podcasts and stuff like that. What do you guys work out of?
I'm with a company called.
Oh, very cool.
I work as a consultant for American Express.
Oh, cool.
But you?
I'm the CEO of Accelerate. We're opening Opportunity Hubs, co-working spaces in rural communities.
So you're opening it up?
Yeah, we have them already going. We have something like this here. Yeah, this is our home base in Salt Lake as well. We have centers open in Price and Richfield. And, we're next going into Vernal and Delta. And,
Oh, so you're going to the places where no one is there? Nice.
Yeah, there's 37 endpoints that have a gigabit connectivity. So matter of doing a proficiency.
Lehigh, do you use Provo and Lehigh?
I grew up in Lehigh.
Oh yeah, so you're planning on opening there?
I don't see that as rural. It was when I was a kid. There was 160 kids in my high school class when I graduated. This year, that same area, there's 4,000 graduates. But Eureka, we have a woman that works in Eureka, which is kind of a little ghost town up on the south side. It's fun. It's actually cool. Some of my team members have to do What's your name? Joel. Okay. So you were saying, you know something about what's the website for like involved schemes, like it's things within schemes, a wider project? Yeah, it's SaltLakeSteam.org. Salt Lake Steam. I can pull it up. Check it out. Salt Lake Steam. I don't mind pulling it up. It's sure. I mean, it's got a minute here, right? I see. Oh, it's actually right now. I don't know. Yeah, my stuff's right. Oh, yeah, there we go. Thanks. See if I can get just one here. Yeah, cool. Thank you. I'll check it out.
You left something out of here?
Microsoft, I think I bring some pizza there.
No, I don't think so. It's there.
Did you send me something? You're Bob, right? Yes. Hi, Brad Stone. Yeah, great guy. Yeah. Education. Okay. Joe Green and I were just talking about it yesterday.
From off the top of my head.
He's from
Okay, yeah. Yeah, okay, I know who they are.
Yeah. So he said that he said that.
I've been working with them in various capacities over the last while on supercomputing. With the putting together, right now we have me and another professor, Christoph. We've got class 7, we've got great programs.
You are, boy, Nick did okay.
What's that?
Nick did okay.
We're gonna another pre-killer thing here. Okay, so now you know who Myers like your whole life, right? So you're saying Chris Myers?
Yeah.
You never did in high school, did you? He went through his Duran phase.
Oh, yeah. And then when he went through like his rap voice phase too.
Because you know when you said that, I immediately went back to like I remember in high school. You know, the TV sport make it. You know, he was like that because I heard. You look like a chick, man. You know, I never said it.
And now he's like a professor and he's like
He had a full-on heart attack.
he almost lost him.
He's running shit. I can't understand.
Yeah, they had to pull him down on 10 notes. They almost lost him.
Yeah. I mean, I saw his posts and stuff, so I didn't know him that well, but.
He and his wife were next door neighbors with Perez and Michelle Obama in Chicago. When he was finishing up the school. I thought I was gonna have some pizza here, but it's not here, but this is gonna be starting back up. You can do whatever you'd like to do. There's a little static shop upstairs. I apologize. I thought we were gonna have some. Yeah.
It's in my hand. Plus your address, right?
So you working for here?
Yeah, just cleaning up a bunch of data. Gets everybody out now.
You're good at that, girl.
Probably, I don't know. Yeah, that's right.
Okay, thanks for doing this, man. I gotta go to work. What's your name? Jim? Nice to meet you. So, I don't know why I haven't met you before. Usually, I heard my act a few months ago, so I haven't been coming to these events so much. But hopefully I'm getting better. Awesome. Best of luck to you.
I know that we've done a lot of work. Yeah.
Sure. Tell me, I'm Sean. Yes, yes. Literally summer.
It's it might be where the conversation might make sense.
So I run the
And it's not straight out of the group.
but I work for
So it's kind of in the vein of encouraging collaboration. And so they go through a few different programs.
Yeah.
The data science.
Yeah. So.
No, you're okay, you're okay.
For regional.
So we're
set up in the server
graphics.
where they set up to facilitate interaction and find something, but they don't necessarily just find somebody to try. It's all supermarket conversation rather than create the idea of something that has to be done. So US Ignite is kind of in that same vein. Yeah, it feels
So is it an ETL tool session? Like an ETL tool?
What is it's just a JavaScript. Oh, okay. So it's a little more clear. And so you could say that Mongo
and kind of brings people to the group, but as their clients around things. If you can shoot.
We're starting to do a deep dive into this day, and it's really interesting. You know, we did a pretty good scan to sort of what data out there, all the dates, counties. In fact, I've got a million rows of data here from counties, check out your data, and cleaning up to loading those applications. It's like there's so much shit out there. I mean, I like what they were saying there. The future is not moving chunks down. It's like you getting in there and analyzing yourself and right back out. It's just massive. And just
Much earlier on.
in years, but they're
sure.
so and that's not already there.
Like I said, it's another place for it would be good to have this conversation.
So you guys got to come in your company. Oh, really?
Yeah.
You're waiting, guy?
No.
And unfortunately, it's out of our clients.
I will.
That's it.
Yeah, we got it earlier today. I had to talk to Ashley when I moved.
And you have problems that
I will, oh, well, no, I'm just saying. Brings up that.
Yes, that's it.
I can, I think.
Well, you know what, let me touch base with you. Under the timeline on this big county data project that I'm doing. Yeah, especially.
Right, are we live streaming again? Excellent. Awesome. Well, welcome back. We're super excited to share with you our awesome panel here on strengthening the big data ecosystem and fostering civic technology. I'm super pleased to introduce, well, actually, they'll introduce themselves very quickly. Let's know who we have on stage. Fernando from the National Science Foundation, Stephen Dennis from the U.S. Department of Homeland Security, Stephen Krieger from the U.S. Department of State, Alicia Johnson from San Francisco Department of Management, and Ian Taylor from the U.S. Department of Commerce. And they each have about 1.5 minutes to introduce themselves, so keep it going. All right. So I'm staff associate at the National Science Foundation.
What's that?
I really want to see you out here.
We're like DARPA for Homeland Security, except a lot less money. So we're scrappier, a little bit more applied. As a personal story, I've always been interested in retiring. So I didn't come from some other area really. But I'm happy to be at Homeland Security, where we have created a little ecosystem for Homeland Security to grow its analytic maturity. So I work in something called the Data Analytics Engine. Now it has a laboratory, an in-house laboratory where one can bring data and figure out what's going on in my data, what are the real problems, and how can I characterize and solve those in a way that's transferable to the human operations. So we'll stop there since it's a short intro.
Hi everyone, my name is Stephen Krieger, and I run the Silicon Valley office for the US State Department. And basically my job is to help engage the tech and innovation community out here in Silicon Valley on global challenges and foreign policy priorities. And big data certainly has a role to play in many, most, if not all of our big global challenges that the State Department is facing. My team out here also helps the State Department think about future tech trends and how those are going to impact the future of diplomacy in the global landscape, of which big data is a big component. And our third mission out here is to serve as a bit of an embassy to the foreign country of Silicon Valley. And so my job is to build relationships with tech companies, VCs, researchers, startups, incubators, accelerators, and of course with the academic community. And we have lots of great, like my colleague over here, we don't have a lot of money, but we have a lot of great challenges. And so for those of you who are looking for challenges to sink your teeth into, we've got some for you.
Good morning, my name is Alicia Johnson. I'm the Resilience and Recovery Officer here in San Francisco at the San Francisco Department of Emergency Management. And background, since everyone's kind of showing that, I don't have a computer science background. I'm maybe one of the very few in this audience that do not have that. I have a background in communications and public administration. So I've worked inside emergency management years and very, very intrigued with how data, big and small, can help our communities become more resilient and help our communities recover more quickly from disasters.
My name's Ian. I'm the Chief Data Officer for the U.S. Department of Commerce. I'm the first person to ever hold that position, and I'm very proud to be part of an organization that believes that we have a responsibility to be America's data agency. Under Commerce, there are 12 bureaus. Names that you may be more familiar with: the Census Bureau, NIST, Patent and Trademark Office, the International Trade Administration, and NOAA, the National Oceanic and Atmospheric Administration. So from weather to demographics to inequality to international trade. We have data on that, and in many ways, we're trying to give all of it away for free while rigorously protecting privacy, confidentiality. A quick example of the kind of stuff we're working on. Just at NOAA, we have, through our sensor network, about 70 to 80 terabytes of real-time, highly structured data coming in per day, 70 to 80 terabytes per day, and we're trying to do all of it for use in your cloud. That's kind of hard for those of you that worked with that size before. And by the way, that real-time feed has a 32-year history on it. So we have some ideas for how to get that all out to you all to figure out what to do with it. And I'm excited to talk about more of how we in the federal government are trying to modernize our data services, bring data-driven decision-making into policy, and how we can serve all of you, our customers, American innovators and entrepreneurs.
Excellent. Thank you, team. So for the remainder of the panel session, I have a couple of questions crowdsourced from our team, and then we'll also open it up to the audience. So be thinking of what you'd like to ask this all-star group of panelists. They're not going to say it about themselves, but every one of these folks is a change maker. They're a strategic innovator. They are working tirelessly towards a vision for their agencies, which is not business as usual. And so the next question I'd like to ask would be to provide some context for the folks in the audience in terms of your struggle to get data innovation in your agencies, and maybe some lessons learned and best practices. What advice do you have for teams who are trying to collaborate around data more effectively?
I'll jump right in. So we basically started from scratch. At DHS for a long time, you were only allowed to study the problem from afar. I felt like it was really important to get your hands on data, and so we luckily had some operational problems where there was data available. We took excess servers off the government excess pile that was 6 years old. We found a rack. We racked them up. We do the experiments ourselves, hands-on coding, figuring out what patterns in that data made a difference, and taking that result from that kind of a prototype forward to leadership is very compelling. And so you show them an example of how data can change things, and then that led to the creation, formalization of our lab. We went from having a rack in a room where we were all sweating. By the way, it wasn't properly cooled, and we kept, with each server we plugged in, we weren't sure if we were going to trip the breaker. But we went from that to having a nice modern facility now, and Meredith knows she was part of our inaugural team here when we built the data analytics engine that's part of Homeland Security now.
Installed storage.
The challenges for the State Department, I think, the obvious challenge is technological. I think that we struggle a lot with having talent, platforms, capabilities, expertise in the State Department to leverage big data to get the insights that we need for foreign policy. But what I would say the sort of less obvious challenge, and what I was more surprised by at the State Department in trying to use data, is cultural challenges at the department. I think that a lot of people, particularly in the State Department, but I imagine it goes across the government and all levels of government, is what a lot of diplomats call the art of diplomacy, and they're very resistant or reluctant to the science of diplomacy. That you can't model things and turn them into ones and zeros, and that's not where you get insight from. You get insight from sitting across the table from your diplomatic counterparts and having in-person talks and bilateral negotiations and things like that. And that many of the situations where our nascent data team at the State Department has tried to kind of model out negotiations, or has tried to use analytics to show what the best policies would be. A lot of people fall back on, are very reluctant to use it and fall back on anecdotal evidence or just their own instincts, which is how diplomacy has been practiced for decades and generations. So I think that that's been the biggest challenge, but as you were saying, a lot of times it's the proof is in the pudding, that if you can get a couple of really good case studies and a couple of good examples that can show people how this can actually be valuable, that tends to be what breaks down the resistance.
I'll just add on to the cultural point. Completely agree. And I'll just if I can do a very quick exercise to show how much that culture stops all data science in its early tracks. So if I can just do this, I'll hijack the conversation. How many of you have ever done a video chat on a web page, so like a Hangout or Skype or something? Have you done a video a video conference, video chat, or use GitHub. Any of them, if you use it. Okay, so that's basically everyone that I can see asks the same question in many rooms, in many government, and the number of responses was the exact inverse. The answer was none, ever. Have ever done it. Not good or bad, just different. So translate to language, translate that to why should I care, translate that to open source, translate that to cloud. You think, wow, we're not, you know, the example of a kind of foreign country that is Silicon Valley, it's a foreign language. It's aliens. It's such a core resistance mechanism. Why is any of this valuable? Yeah, it makes sense why so many of the entrepreneurs that even on the stage have had such as far as we have. It is fundamentally a change of thinking, a change of method, a change of business. How do you measure success? Do you know who your customer is? Do you want to have a customer? Like, these are the questions that I think are more at the core of data science in the early stages. Now, the tech is hard and fun and big and wonderful. There, you need money, right? And so that I think is I completely agree with the comments.
From a local government perspective, it's exactly the same. If you speak about it in business terms, you're looking at a massive chasm between early adopters and usage. And that exists both inside the organization and on the local. A massive chasm and one that absolutely must be crossed in the 21st century. Wow.
However, our major problem is separating sociology to computer science to mathematical science. And when we think about data science, just like a key priority area here is that I talked before our director just gave a presentation on National Science Board, and data science is the first area, major area of investment during the last talk, right? You have to think about really how do we support all of these different disciplines. Some of them were more data savvy or less data savvy than others, right? And I would say that they're maybe less data savvy. I think they're data savvy in different ways. If you're a sociologist, you're managing your data in a totally different way than if you're working on a big experiment like LIGO, something like astrophysics, right? So we have to think really hard about how do we provide that support in a way to every community. And that's a very, very hard question. This is the data heterogeneity question, right? It's the different communities question. And also thinking about how different communities may support each other, right? Data science is not yet usually a field of or discipline in a university, right? You get a master's degree. So there are a few places that have tenure track science right now. And so when we think about that and we think about the structure of the way the science, how do we make that transition into this fourth paradigm? I think that's something that NSF is thinking about very deeply right now.
Excellent. So to recap, it sounds like hands-on experimentation is good and possible in government. We are, as data scientists, potentially aliens and face cultural barriers when we're trying to scale and innovate. And there's a massive chasm in terms of early adopters and scaling to broad participation. Did you get that okay? Excellent. Did you get all that, Dana? The second question that we have from the crowd is going a little bit to that personal story in terms of what Jennifer and Kathy mentioned. What drew you guys to work in this field, and what has been most meaningful to you in your tours of duty? And anyone can start that off.
I can start first, especially since I don't have a computer science background. I got into emergency management because I wanted to work in public relations. Which I know sounds absolutely ridiculous, but I found out that I was actually really interested in risk communications and working with individuals on points of risk and how to become more resilient. And I became very interested in technology in general, data during the earthquake and tsunami in Japan. at the time in Utah. Props to the folks from Utah. And I was goofing around on Twitter, and because there is a very large social media and emergency management group there. And so I was kind of hanging around, just looking for things, and I saw it happening in real time. And I started to understand how quickly social led to data and how we were able to gather information from that point. And then I went to bed rather late that night and barely pulled myself out of bed the next morning. And the thought occurred to me, what are we doing with that now, right? The earthquake, the first wave of that is over. Obviously, there will be aftershocks, but what do we do with that data now? How do we use it as a government, as an entity to help these people who have been impacted and become, again, more resilient in the future? And so that was, for me, one of those real world impacts where I thought, and data itself, big data, small data, social data, really made a difference. And I've seen that now in many disasters since then. And I've worked a few events that have brought that to the forefront. Again, there's a massive chasm. People who don't understand that, or who have yet to see that impact. And I think that is one of the things that compels me to move forward in this area.
For me, this work is all about public service. My passion for this type of work that I do now started when I was in college. I was a senior in college when the terrorist attacks of September 11 happened. I went to Georgetown, and you can see the Pentagon burning from my door. You can look at it, you can see it on fire. At one point, I decided to serve my country. I was in the Navy for 9 years, and served as a counterterrorism officer and later as a nuclear engineer. That's what led to the tech thing. It's all about public service. It's all about how we can help people. I think data helps a lot. At this point in my career, I've worked for over 200 governments in various capacities, vendor, employee, private sector, every way you can cut it. And every time I have another opportunity, I basically jump into it through a strange addiction. And at this point, I'm believe on my core that information can create jobs and it can save lives. And I've seen it in my current work. Another example, we have a notification system before, for example, tornadoes, where even if you did not sign up for the service, you will probably get a text message that says seek shelter if that tornado is about to hit you. It averages for about 5 minutes. Now it's 30 minutes. And I don't know if any of you have kids, but I do. I have 2. I'll take those 25 minutes to seek shelter. That's data in action. That's data that can save lives. And I want more of that, more people, so that we can fundamentally improve the way we live our lives.
I was, to answer the question of how I got involved in this, so I'm also not from a science background. I was a journalist actually for about a decade before I came into government, and I was brought in to work with the Defense Department to work for Ash Carter, who's now the Secretary of Defense. Who's actually in town today. Sure, yeah. I had breakfast with him yesterday. He brought me in as when he was the Deputy Secretary of Defense to bring in new ideas to the Pentagon and think about how we can make a massive bureaucracy more innovative. Let's not be the first sclerotic, hierarchical bureaucracy to think about how to make our workforce more innovative. And so I was asked to go spend about a year looking at private sector and looking at some of the best practices for how do we develop new ideas and new approaches, do things more efficiently and effectively. And so much of what I did intersected here with Silicon Valley and looking at how to leverage technology to better accomplish our mission. I went over to the State Department to run, to actually set up and run an innovation lab over there, which borrows a lot of the similar playbooks from innovation labs out here in Silicon Valley about how do we bring new ideas and perspectives to our foreign policy challenges. Setting up a State Department office out here in Silicon Valley came from the recognition that, first of all, a lot of the major tech companies out here are having more of an impact on foreign policy and global affairs than many countries to which we have full embassies to. I said in a previous speech to most countries that we have embassies to, but I got in trouble for that, so not to say more to many countries that we have embassies to. But and also the recognition that tech as a tool can really move the needle on on a lot that we care about. And just to answer quickly about your question about this inspiring story, one of the first projects that we did out here was about how do we leverage the tech community to help with the challenge of Syrian refugees. And we put out a shingle, said we were going to put out a workshop at Stanford, and we had over 120 different tech companies and individual engineers and developers and coders came to this event, and after a couple hours of working in different teams, came up with 8 prototypes for different products that could be sent immediately out to refugee camps. And at this point, 4 of those 8 ideas are out there operating as prototypes that were developed in this workshop from people like you here in the room. That made my government head explode in terms of, what we could accomplish in a day, and maybe like a couple of weeks after that would take years to accomplish in the government. We have to use a federal contractor, have to spend millions of dollars for a solution that doesn't even really work. And so I just have seen, and since that time, since so many case studies on so many issues of how the tech community can get engaged and really move the needle on huge global challenges.
If the audience has questions, if you could be so kind to raise your hand, Christine Kirkpatrick, our Deputy Director, will make her way to you. We've got one over here.
Whole big change in
He's a
transparency.
former AAAS fellow and Bay Area tech advocate here. Please introduce yourself briefly.
And I think a lot of the value from our data comes from applying it in other data sets.
You may like your lunch or lunch?
And one example of this, when I looked at maps of HIV incidents in Africa.
Looks like the pizza's not coming, but we can
really go.
probably just go in with something upstairs.
Oh, these outbreaks are being spread along the road.
We've got a Chinese place, and we've got a sandwich place up here.
So there are great insights being found in finding.
I'll support for pizzas. You guys give me an idea. I can probably get it here pretty quickly, or I can do Jimmy John's and just do some sandwiches. You guys tell me. Sandwiches?
So my question to the panel is.
I'll do like 5 big sandwiches, assorted things. Anybody have any dietary issues?
Don't tell me I gotta take off.
Done. They'll be here in 15 minutes.
Proprietary good success stories or models or thoughts on how we can do a better job of freeing up that data so that we can create either business value from it or social value.
Absolutely. So here's a quick plug. For those that have laptops in front of you and cell phones, commerce.gov/data usability. Commerce.gov/data usability.
Sorry, that's the wrong one that we put out, but that was the other side that you wanted. It's another thing you could
I completely agree with you, sir. I completely agree with you 100%. Having done this many times, just opening data for open sake is very effective in most cases. Even if you can get good information out, it's hard. It's very, very hard for business, very hard for anyone who's concerned about privacy, very hard for government. But even if you do that, it doesn't have the business or social impact that thing to talk about. What's actually required is to publish information with the metadata, with descriptions. But in itself, I believe that even if you have the perfectly designed, perfectly articulated, defined data set, how's it going to find out what to do with it? And so I think that especially I can speak to government responsibility, a lot of what we're doing right now through the data.gov movement and others is not just to get the data out, but to tell the story around it. Why is it valuable? Who can it be useful for? And then after you upload it, engage with those communities and advertise it, iterate, test with customers, treat it in a lean, agile fashion. Is this helpful? What else do you think would be helpful? And then have a responsibility to go back inside and say, okay, we tried this. We think it's helpful here. We actually heard this from communities from a business perspective to make money, from a social perspective to improve lives. And now we have to go back and iterate and just have that be core to our function. A lot of governments actually have publishing data as part of their mission, the Census Bureau. They've been publishing the count of population for a long time, right? So it's actually part of their core. It's more of how do they publish that information? so that you had the most effective outreach and connection with all those different opportunities. The private sector perspective of that is a little different I think, for good reason. It has to align back to that cooperation. And I think that's the larger message for a lot of what folks are seeing here. Data science cannot be a peripheral, it can be an appendage. Data-driven decision-making can be a nonprofit side project. If the more it is core to the operations of the business, the more likely you are to accomplish your mission. And if the open side of that can encourage a larger ecosystem community, the better we all are at accomplishing our goals. And so, you know, for us, we're eating our own dog food. I believe what I said very dearly, and with the folks at the Department of Commerce who are working very hard to get that information out. That one example, the one website I talked about, commerce.gov/data usability. How we're starting to really do more than just open the data. You have to define it, you have to give the code snippets, you got to give the API accessibility, you got to have feedback with the private sector communities to know how to improve that stuff going forward.
Yeah, sure. I'll just jump in and say, first of all, that every experiment on security and data begins with privacy and civil rights and liberties. So that's the most important thing that we see around our data sets. It's taken very seriously and documented. That said, though, I think there are data sets that Meredith was able to actually move from DHS to help them from FEMA related to disaster response and missions like that. It is possible to move data sets out. I think it's important to build on what was just said, that where self-service data is enabled, and so you're able to yourself go and see, without a significant background in computer science, you should be able to go and see what data sets can come together to make a difference for you and your analytics and your story. And so that's something we push inside of DHS, trying to get role-based access so you don't see things you're not supposed to see, that you can't exploit the data in some way it's not intended to be used, but yet allow the data to be used in an analysis where that information isn't exposed. And I think there's some exciting ideas that are on the table relative to that, where one will be able to keep data encrypted and be able to do calculations beyond encryption. But the proof will be in the pudding on those.
I'll just add one thought on that, is that that's something that we struggle with a lot at the State Department, where you have, a lot of the data that we have is very sensitive information, classified information, so it's very hard to get that out to the public, though we are, like my colleagues, trying to find ways to shift that out, where like most of the talent is on the other side of that fence. And so we want to get out there and create those intersectionalities that you talked about, which is where a lot of the best and most interesting insights come from. But a realization that's finally sort of dawning on people at the State Department is that a lot of the most important data out there is actually no longer created by the U.S. government and owned by the U.S. government. And actually a lot of the challenges that we work on are created by the private sector. And so we can actually engage the private sector in constructive problem solving. And I'll just give one example. We did a big workshop last month on leveraging open, sort of publicly accessible data to track nuclear weapons. A task or function that historically been done only by the U.S. government, because we had the satellite imagery, we had all the information related to that, and we collect that information, microsats and internet of things, and ubiquitous sensors and drone imagery and publicly purchasable satellite imagery. The public can actually engage in some of these things, and I being a relative newcomer in that space, I got a lot of angry emails from sort of traditionalists in the nuclear space saying, what are you doing engaging the public on something like this sensitive? This is something that only governments should be doing. It's such a sensitive thing. I'm like, well, it's not. We don't have a choice in that matter anymore. Like, the public has access to all that information. Even if we, U.S. government, don't release any of that information, they can still get engaged in these kind of things. So it goes back to that another cultural shift that I mentioned in the beginning, that a lot of the most pressing global challenges, the information is already out there in the public sphere, and so there are lots of opportunities for the public to engage in this creative problem solving.
I'm finding Jupyter in the audience because he was wearing a hoodie in the back. So really noted that you integrated well into this culture. Were there any other questions from the audience? Aaron could run back to one more question. Oh, you have a question? Oh, of course. Aaron, one of our co-principal investigators for the Hub.
So I wonder if to how you think that there seems to be that smart future of
Ben's bias. So
Yeah,
I don't
well,
know.
I don't mind asking. We have a lot of needs in my experience. So this is a very well-positioned community to help us solve problems. And so I just throw out a few. We worry about for the whole Internet of Things, which is really buzzword. For that whole sort of area of data that's going to show up that either enhances or distracts us from what we should know. How can we get to good analytic systems for what I would call multi-party, mixed latency, multi-scale network? So if I need to do real-time decision making, have time transfer decision making, understand what the system can actually produce for me in terms of an analytic result that I can use for decision making, and can I understand the error bars around that analytic? And is there a way to instrument the people and the system in a way that lets me take advantage of those time frames in order to do things like maybe if I wait another minute, because my error bars are changed drastically and I have a much better decision that I can make. Being able to do that in the heat of battle is something that would be really good. Getting to good IB&B methods for machine learning models would be good. How do I know my models are ill? How do I know that they need to be replaced? And when I do that, I'm not going to do damage to an operating system. Or I have a bunch of these.
There's breakout sessions in the afternoon too that he's gonna follow up.
So one thing I worry about too is the level of autonomy that we've reached in society and we're reaching now, where we have a lot of model-driven decisions and machines are going to produce information, perhaps to feed high-consequence decision-making. And so what should the governance structure for that look like? It's like a perfect confluence of policy and is there a way to prepare next generation governance on how to deal with those technologies, whether it's driverless vehicles, or it's autonomous UAVs, or it's healthcare and surgical robotics. To me, there's this cascade of decision making that can go on in systems like that, and how well do we understand it, and how well should we understand it, and what is the role of government there?
Maybe I'll answer this a little bit from the NSF perspective, which is odd because I think NSF is funding the hub. So what do the hubs do for us? So I think if you do step outside of what just the hubs are thinking about, really think about the hubs as a way of going beyond that fundamental research that we support. So if you look at NSF initially, number one is promoting progress in science. Number two is supporting the national prosperity. And if you look at our review criteria for every proposal that comes in, number one is intellectual merit. Number two, it's not number two is in terms of its weight, is its broader impacts. Right? So we think very hard about when we fund fundamental science and computer science and data science and all the related sciences, how do we transition that into practice? How do we actually make the impact that it potentially could have? And I would like to see the hubs be a way to link communities of researchers with those communities of end users, and for them to both inspire each other, to have end users inspire for research, for end users to be able to see what are the potentials out there for technology.
And as an end user, I have many challenges to inspire you. In all seriousness, a lot of my job is basically working with the 25, 30 different bureaus across the State Department to surface where are the challenges, where tech solutions might actually be helpful, and particularly in the big data and analytics space. And just to sort of name a few that we've been trying to engage with the big data community on, Syrian refugees, countering violent extremism, looking at social media analytics, looking at sort of social networks and how extremist groups recruit and foster extremism online. I mentioned the nuclear weapons one. There's a lot of really great big data challenges embedded in that issue. Predictive analytics for conflicts, like what kind of factors lead to conflicts breaking out, and how do we better get ahead of those trends? Like that's something that we're really investing in. Data analytics around foreign assistance, like how all the millions and billions of dollars that we give to countries in foreign assistance, how do we analyze that data to more effectively distribute and assistance? And there's probably like 10 or 15 other challenges that I have in my saved on my laptop over there in an ever-evolving Google Doc, and so which we just got permission to start using at the State Department. And so, yeah, and so we're to more directly answer your question. We are looking to partner with NGOs, independent researchers. If you want to get involved in these projects, if you want to make an impact on some of these global challenges, please feel free to reach out to me either Twitter or through LinkedIn or whatever social media channel or email addresses up there.
Actually, all the panelists agreed to put their email addresses up there, so please.
So that is essentially my job out here, is to engage with the tech and innovation community out here to get your guys' insights into what we're trying to accomplish.
From a local perspective, it's actually remarkably similar. There are a lot of challenges, of course, on the broader civic side of things, so looking at economic stability and then the disaster element of that recovery really look like what's vital to get up and running as possible, and how do we do that effectively, and using data to help us understand which decisions are most vital in the first 72 hours and which decisions can wait. And that type of answer right now and has always been derived from experience and very similar to the art of diplomacy, right? There's that element of we've done it this way and it works, so we're going to keep doing it that way. There might be a better way. I think that's one of the elements. The other question that's really on my mind, and I hate to answer the question with a question, but right now we add technology to civic action or to make it what we see as to make it more efficient, or what we think is more efficient. But the question that remains for me is what would happen if we made technology native in civics? And what does that really look like? How might we make that happen? So that's one of those questions that in my mind is really lurking in the corner related to local government, is how do we make it more obvious and more native as opposed to just slapping it on top and saying we're technologically friendly.
Civic proposal. We have this thing called City SDK. It's a software development kit that is entirely trying to translate a lot of the local, hyper-local data among people's communities in a way that you can make people accessible and translate to all the work that you're doing. It's put up by the Census Bureau, so if you were to Google City SDK Census, you'll find it. It's on GitHub. The suite of data translators can very, very specifically help anyone who's working anything that involves people. So if you're working on demographics, measuring income, homelessness, business growth, where to open your new business, anything that counts people in the location matters, we have an SDK for that. It's called City SDK, and I would love to work with this group and all of your different ecosystems, every group you're part of. We'd love to hear from you. If you are here, is it helpful? What should we do to it? How can we make it better? How can we make it more valuable for the work that you're doing? Because at its core, we believe that measuring is a very important government service. It's Article 1 of the Constitution. And we just want to find a better way to get that data out to you all. So that City SDK, I'd love to hear from this group, a partnership around that, an opportunity to see if we can improve that suite of tools.
Last thoughts about engagement from the audience that you'd like to share?
I had a question.
Okay, if you can be really brief, because you told me last night I had to be a really ruthless timekeeper.
Oh.
Go for it.
I'm the director of the San Diego Supercomputer Center, and I'm one of the 3 PIs of the Western Hub. One of the unusual things about the way we've been set up is that we're regional. And we've heard about national priorities, we've heard about local priorities. I would just like the panel to briefly reflect on how you see in us being regional.
I can give you the answer that this came up with, because we actually did a very, very long process of design for the West Hub. We had a whole their suggestions, series of hubs in the United States, what would they look like, right? And so we came out with regionality because we realized that a lot of what was lacking about, and then the purpose of hubs is to build partnerships, interesting projects, partnership projects. that attack problems that aren't being addressed today. Offer two things. One, it offered people an opportunity for face time. We want people in this room to go out there and actually do projects together. Not just talk about how big data is great. You can read any blog and figure out the big data is great. Actually work with somebody and to be able to do those projects where you really have to have face-to-face interaction with somebody on a regular basis. So regionality actually keeps it so you don't have to always fly out to be able to meet with experts in data science, right? You can meet with the ones that are in your local area. Two, there are certain priorities that are regional, right? That a certain set of states might share. The West has certain priority areas in the way that big data can be applied. It's very fundamentally different than, say, the Northeast corridor, right? And I wanted people to actually be able to find synergies more easily and priority areas more easily. So that was one of the reasons that we really thought that the hubs could be regional. There are lots of national initiatives on science, biology, data science, and environmental science. They exist. They already exist. There's lots of good organizations that exist already. So we wouldn't be filling much of a gap if we just created another series of nationally based data science initiatives. So I think we'll hopefully find that this is sort of a unique, very lively, integrative kind of environment for you to interact in. At least this is my hope. This was an Anastasoff.
Pretty unique and lively. And with that, I'm going to wrap up this panel so we can stay on time. Thank you so much, everyone, for joining. So we could bring our next set of speakers. So we're standing in between you and lunch. And so this next experiment is paired speakers. We've got a 1-2 punch for each of our afternoon breakout sessions. So you'll hear from each of the 7 teams. A visionary outlining some of the challenges in that arena, followed up by specific ideas on how we might brainstorm space in our breakout session. So first I'd like to bring up for natural resource management and hazards, Linda Basta, who is a senior advisor and the data analytics engine for the U.S. Department of Homeland Security, also HSARPA. And she will be followed with Mike Norman, who is PIs for the West Big Data Innovation Hub, and also the director of San Diego Supercomputer Center. Linda, Mike, please.
Good morning, everyone. Thank you, Meredith. Thank you for allowing me to be amongst such esteemed colleagues. I would also like to shout out here to my boss, Steve Dennis, and also another HSARPA data analytics colleague, Alex Kunzahat. She's with us today as well. I was asked this morning to talk to you a little bit about the natural hazards, and the co-PI, Dr. Norman's going to be speaking after me. And that affects, is of most interest to this particular topic. I saw a show of hands, and if you wouldn't mind indulging me in one moment, please, those who are from California, could you please raise your hand? What is our single most natural hazard threat right now? Water. Pardon me? One more time. Thank you very much. And that's what I'd like to address with you this morning. To the rest of the group, national issue. Okay. Just wanted to give you a couple of statistics, if I may. According to the U.S. Drought Monitor, this is as recently as of this morning, I checked the data, 70% of the United States, including Alaska and Hawaii and Puerto Rico, fall into the category of drought. Pretty staggering number. Of course, California, unfortunately, is in that state of where we're in our multi-year drought. And of course, those of us who mostly within the state and who are residents of the state feel it, more importantly, feel it significantly, I should say. The It is a national issue. March 2016, for those of you who don't know, the president published the long-term drought resilience federal action plan of the National Drought Resilience Partnership. Of the 6 goals of that partnership, reads goal number 1, integration. Integrate existing data and information for regional level use. And this gets back to what Alicia was talking about, in terms of regional level use. Also, enhancing national data, facilitating citizen science with regard to our tribal partners, and being able to enhance those protocols. Now, granted, these are responsibilities that the president has indicated to federal governments, but it involves our regional, state, local officials. Those are directly involved in emergency management. The impacts of the drought. Well, it's not just about, oh, I was going to use the prop. It's not just, it's about the water. But it also impacts other issues. The long-term modeling weather maps that we had, because the weather patterns, because of extreme weather, we're going to call it extreme weather, they've changed radically. Very difficult. Jurisdictions, state, local governments, etc., to plan, even in construction, infrastructure that can withstand 25, 30 years without knowing what the long-term implications of the weather are going to be. The weather patterns are constantly changing. Existing infrastructure. How do we make it more resilient when we don't know what the weather conditions are going to be, or the weather conditions are constantly changing? We have deteriorating infrastructure due to the, in particular, for those of you in California, one in particular concern would be, of course, our levee system. You well know that particular issue also. Our first responders. How's the drought impact our first responders? Well, here's another interesting statistic. 10 years ago, typically California had a wildfire season in late summer. They had an average of 1,200 a year. To date, now, our wildfire season is almost annually. It's wildfire season. It's no longer a 3-month wildfire season. And as of last count, we're currently close to hitting 900 wildfires. We have not even gotten into the latter part of what would normally have been the wildfire season. Direct relationship with the drought? Absolutely. Of course, then we have the deforestation issues and the like. We have agricultural impacts. We have residential water impacts. There is a community, small disadvantaged community in the Central Valley of California. It's been without drinking water for 2 years. They have, fortunately, obviously, they're being delivered bottled water and the like. But just to put yourself in that situation in terms of not being able to shower, just the human side of this is just staggering. Get to the point of what do we do when we have a disaster where we need the water, such as if we have another catastrophic event, like an earthquake, that we need to respond to. So it's a challenge that we all have. We know much research and data sets have been generated by many stakeholders out there, federal government, our very progressive state and local governments. In my how do we challenge, how do we gather this information to help stakeholders make informed decisions, make informed and timely decisions? I know there's been some portals for the Arctic Circle that I know NASA, JPL partner with the National Science Foundation. Or to you, I'm not suggesting this is the way to go, but how do we as a community come together and gather this information so that we can create, in the end, actionable intelligence for not only our federal, but also our state, local, our communities, as well as our first responders. And with that, I'm going to turn it over to Dr. Miller.
Thank you, Linda. We actually did rehearse this. That's a perfect setup. Living in San Diego, we contend with wildfires every year. Something that is regional in the West. And so it is one of the motivating factors for the work that we hope to do in the hub. So what I'm showing here is just a list of the titles of the letters of intent that were sent to the hub for the SPOKE competition. We don't know to be funded at this point, but as you look across this list, you see a lot about water, disaster management, ecological sustainability, and so forth. A flavor of what one of these projects looks like, I picked this one at random. I don't know if there is anybody in the room from this project, but it just gives you a flavor of what people are thinking.
Thank you. You're going to steal my idea.
So this one is a project called Roads in Mountain.
You are. They are.
It focuses on the 6 Colorado River compact states, setting up a data sharing federation for better water management, resource management. Their approach would be to take something that's already working in Utah across the 27 counties, which is a federated data setup, and pushing this as compact states. A number of federal agencies will be involved, and a variety of academic and local government institutions will be involved. Looking across all of these letters of intent, which I read, you see some common themes and needs: enhancing partnerships, data sharing, data federation, data integration, preparation, disaster response, resource planning. Is, of course, big. Now, my center is where computational science and data science come together around real problems, real challenges. And the thing that makes this all go, of course, is the human expertise. It's not commonly known that my center isn't just a building with a supercomputer in it. It's actually an e-science institute with a supercomputer. Most of the people at the San Diego Supercomputer Center, there's 270 of them, are data science type people that work on these integrated solutions. There's a few of them there. I'll skip over our Coursera course, which has made us $3 million, which is makes me very happy. But as I look into not just the natural resources and hazards area, but look at most of the thematic areas in our Western hub, it comes down to this, and we've heard this already from previous speakers and panels. It's dynamic data-driven decision support for both science and societal problems. And our view is you've got the data sources, computational platforms, whether they're in my building or in the commercial cloud, it really doesn't matter. You want to fashion solutions that can do this sort of thing. So I just wanted to give an example, a work example, done at my center for wildfire resilience. I think is what we need to be focusing on across the board. And this is this actionable data. So this is a project called Fire, funded by the National Science Foundation that integrates a variety of data sources through automated workflows into situational awareness and prediction for the local firefighters. And so if I can see if I can make it run, I'm not sure I have the technical capabilities to start on this Windows 8 platform. I'm a Windows 7.
Windows 10 Surface, but we might have to accelerate this for the sake of time. Data science is team time. We have a whole team here between us and lunch. So how about we?
Okay, skip it.
You might get the break to watch it.
Okay. So anyway, what you would see there was Los Angeles Fire Department and how they could just pick a region and launch a fire simulation and ask what is it 2 hours later, 5 hours later. And that's the sort of thing that could be done regionally with this kind of technology. So with that, I will just hand it off to the next group.
All right, so to keep on time, I'm going to stop it here. We have Professor Pham from UC Berkeley, who will introduce our precision medicine working group. And for the sake of time, she will be followed by Arnold Rippon.
Well, thank you very much for having me here. So let me introduce myself. I'm a statistician, data scientist. I will call myself also a realistic optimist. So you see why? Because the reality is very important and the optimistic too. So I think the ultimate goal of precision medicine is really trying to improve human health for all and at an affordable cost. It's not just a few people benefit. And I had to go through a big health episode 2 years ago, and so I want to see it from the patient perspective. Patient loss. What's the diagnostic? How did it happen? Who else in the family might be at risk? How can we expect in the future? Is there any treatment or cure? What's the cost? Does insurance pay? And I think almost all questions big data can help. But however, not absolute. So you see, I have 2 photos there. You can see big data looks a lot simpler than the complexity of life, and that's also true in reality. We need to find low-hanging fruits where the big data can help, not over stretch ourselves, because the consequences here is huge relative to IT applications, learning neuroscience, remote sensing, and signal processing, all that. But the cost here is not just average. We cannot say on average we save people, but we kill the people, right? It doesn't work. In IT and business might be okay. The average revenue is good, but so individual cost is very important. So I want to expand on the first 2 questions and give you a sense of the possibilities of hope. One, I think the early success story of big data in precision medicine is actually clinical genomic diagnosis of early childhood rare diseases. At UCLA clinic, they were able to diagnose 30% of undiagnosed rare disease cases. But I want to emphasize that a lot of the well-posedness of solving big data problem comes from prior knowledge. Literature, and here, the clinicians already identified by symptoms these kids are having problems. So you zoom in to a very small group of people, you know you can find things. Like looking for a needle in a haystack, it's hard. But you can localize to a smaller region, become more visible. Big data is big, but complexity of life is so much more than the big we have. So how do we resolve the tension? And the second example is here from my group working as LBL scientists about the e-news and all that, is we learn a lot from doing experiments on model organisms. So for the rare disease, actually this project we work on is on the software is cheap to keep, you can manipulate, you learn a lot. So how can you bootstrap up about human? And I hope that I will stop keep funding such study organisms that just go all the management of humans, because Drosophila shares that 75% genes as us, so not that much sophisticated. And people already use Drosophila as a model to study diabetes. So that's another source of prime information on how to solve the big data puzzle. And one principle I want to choose, usually I think it's easy to use and you're advocating, is this concept of stability. In manipulate data, use only 90%. Or do data preparation, and like deep learning people have been doing, have kind of half real, half synthetic images, and put with your data, and you want the conclusion as a whole. I would think this stability is the minimum requirement for scientific reproducibility. I advocate it strongly because it's very relatively easy to use. You can also combine dynamic system concepts, stability. I think two things we can, in principle, in big data very useful is prediction, which machine learning has popularized it. You don't have mechanism, you cannot integrate them. You don't want little bit data change, your story change. That's just to a 10-year-old, you can explain that. Those are very key. And I have a paper from 2013, and that's one ingredient introduced to the project in terms of new thing. Metric visualization is based on stability. And in terms of modality, besides genomic, geometrical data, and fast, and technical challenges. Data sharing is a big elephant in precision medicine. I've co-lead a project with the Cambridge University and National University of Singapore. The different ethnic groups are very important. But there are legal barriers within the US. Actually, I cannot access UCSF data easily. So the data sharing doesn't get solved. All the promises of real data will be realized. And data normalization, the data from different collections cannot be just done together in kind of they have to be normalized, properly remove the batch effect, all that. And also validation and scalable computation will be a lot. A human challenge in the actual early speaker is that all these supercomputer personnel are only 200. How can we have 1,000? Or have more people with less than this is 200. The other thing is communication between areas, government, industry, academia, and the academic winner takes all systems reverse and has to change instead of individuals. And we need to have patients involved in a formal way. I was a patient 2 years because I know how difficult sometimes to get the doctor to listen to you, and also accountability problem.
Okay, I'll be really brief. We'll have opportunities to talk more about the role of the decision medicine later in the afternoon. I'll talk a little bit about, highlight just a little bit of the challenges, I think, the opportunities that exist in big data. I think two things in life are certain. One is that we'd all wish that our taxes were easier to do. The other is that we will all touch sooner or later in our life. And so electronic health records about our health are ubiquitous. Problems are really big. Electronic health records and data about medicine and about human health. Social issues, political issues, legal, scientific issues are complicated, technical issues are complicated. This is really, but we think that we can start tackling that by coming together to think about these things. So some of the ideas that we might talk about during the afternoon are examples in which data can be made available to others to do research with. How do we address the situations where it's challenging? How do we remove the barriers for data sharing so that many researchers can access the data and find solutions to problems related to health? And then the idea of team science that is so important. How do we make team science valuable to participants in this endeavor? One of the issues is, of course, scaling up expertise. The teams that are doing research, data carpentry, about software carpentry, education is a big issue, which will also be brought up in others of the sessions later in the afternoon. I look forward to talking to many of you about these things later today.
Thank you, Aria, and the protein database that's below via Twitter. That's your data science with Pham.
Control. So I want to give a couple of examples of things we're doing on the national level and sort of talk about a few things going on specifically in the West. And also through the story here, convey some of my excitement in this space. So over 50% of the world's population lives in urban areas, maybe 70% in some number of years. Cities are the lowest economic, political, and social activity worldwide. There's been studies from the Brookings Institute and other places that demonstrate this in no uncertain terms that they're the drivers of change as opposed to state government, as opposed to federal government. North America is already 80% urban and predicted to be 90% by 2050. All 4 of the NSF regional hubs have a urban data science thrust of some form or another, including us. And also, one thing I especially like about this is the problems are approachable and relevant to literally everyone. If you have a data science for microbiology event over the summer, you're not going to get as many applicants as you do when you have a data science for social good program as we have done. So this is great, but these study of cities kind of resists reductionist approaches to science, right? Everything's kind of interconnected. And say, well, we're going to study waste, we're going to study water, we're going to study transportation. You're going to have perverse incentives, you're going to have sort of side effects, especially in terms of equity, that can cause a real problem. This is the Perez favela. Buildings behind that are one of the wealthiest neighborhoods in Sao Paulo, Brazil, and this is where people are living here in the favela in front of that. And so the disparities that can emerge if you don't managing property are pretty severe. Okay, so the good news though is that open data, as we've heard from the panelists and speakers today, is transforming things. So Crowd is a local sale company who's one of the pioneers in this space. They've made a real successful business in jailbreaking city data from local governments, especially driven by our Freedom of Information Act. Just to respond to those requests and more rapidly release that data out and let people. We're also very interested in finding the application stack as opposed to just dumping data out there. As we've heard from others, they're very, very hungry for working with that data, working on analytics, working on visualization, working on apps, and so on. So they've been a great partner in this space. That's the situation we're in. The federal government is aware of this focus on this. September 14th last year, in 2015, there was an announcement from the White House about $160 million. It's not all new money, so it's kind of there is a concerted effort to invest in this space of smart cities. Much more recently, with the police data initiative, just in April. Parking transportation did something really, really smart, which was concentrate a lot of resources and put together a prize. So this is $50 million. So $50 million instead of sort of handing out 100,000, 200,000, and so on, and going to small scale things. It was just one city, and they had an absolute enormous response, way more than they expected. So they actually only limited to cities of a certain size. So you still had 77.
Get your attention, huh?
Respond to this thing. So a little bit too small to read, but they were blown away by this. Every sort of blown away by this. So they seem to be on the right track. I think from the proposals that were in, the people are ready to respond to these things. They need some more funding. And that's what this is a demonstration of that. So this is in phase 2. There's 7 cities that got past phase 1, and we'll hear more about that soon. The Global City Team Challenge through US Ignite and the National Institute for Standards Technology is another successful national consortium in the space. They put together an annual event, a showcase of various projects. So they're well supported, well regarded. If you have projects you want to show off, submit there. The Smart Cities Council represents.
We do have a contingency going to Austin with that in June. So if there's any ideas that you want to propose or to put into the mix, let us know.
Probably letter from Anastasoff about Smart Cities work just recently that I'll let. I just want to leave a little bit of time for my favorite one, which is the Metro Lab Network. So this is 20 and now 35 city university pairs who signed a formal agreement between the mayor of the city and the university leadership to commit to advancing smart cities work. And the key differentiator between this and the other formal agreement between universities and cities, that no one can either unit can do it on their own. This is funded essentially by a $1 million grant. There's 100 projects in the catalog so far. I just got back from the first summit of the Metro Network. Governor Mark O'Malley actually is joining the team to lead the National Advisory Board. He's a presidential candidate here in 2016, and I was looking for work, I guess. So, this is, we're pretty excited about this, and this is just getting started, so keep an eye on that. And then finally, before I hand off to Sarah, I can talk about something going on in the West. I want to give some thoughts about how the hubs fit into this ecosystem of programs and efforts going on. So one thought is that the whole house could come crashing down if we don't solve this tension between open data and privacy. These are just from the last couple of weeks, a couple of headlines here. These sexual assault victims, the names have been released online for public data release from the police department, part of routine open data release. The laws get changed, and all of a sudden there's more open data and more rash happening, so you can't screw up like Dallas did here. So that's a real issue. This is a less real issue, but it's more the optics and perception of it. There's a series of articles about, hey, you probably should use public Wi-Fi in New York City because they're all tracking your MAC addresses, and we're really scared of that. This is not a particularly meritorious argument, but it's out there. So you really have to deal with these perception issues. You have to sort of do this in a smart way. And unfortunately, you can't treat this as a technical problem, right? Those are the results in where you can't actually prevent anything. You can't do hard guarantees to prevent bad things from happening. It's more of a strictly technical, legislative kind of approach. And I'll recommend taking a look at this in doing sort of the first of its kind national legislation, how your private data for a series of principles. So take a look at that. So that's number one, is balancing. So maybe what the regional hub can do is have norms for balancing privacy and open data. Number two, there's a popular concept of kind of an urban living lab where research from the university can be actually deployed and practice in the city and learn something. To a regional living lab as opposed to a city living lab. Something like the big data hubs. I have all these things. I think that's a useful area to put into. Designing distributed experiments across geographic and political boundaries is something that no one city can do alone, but we can maybe not do. So, Portland and Seattle have certain things that are similar about them, some variable sticks, and try some in different places and measure the results. Number three is coordinate and amplify the regional responses to some of these federal opportunities. This is another layer of hierarchy that we have now access to through the hubs. Limited access so that the Metro Lab network, for example, doesn't have to call 100 of the universities, they can call the Western Data Hub and get access to that. You can also put the R and RD&D, like the Metro Lab network, you like this phrase RD&D, research development and deployment. That can be a real model of what applied research should be. But they, NSF, kind of owns the R in that, right? So they need something like that Western, the Hubs program to participate in that. Okay. And with that, so those are the three starter ideas to think about during the breakout. Of course, there's other ideas you guys may have. And with that, I want to turn it over to Sarah, who's going to talk about some specific activities that are already going on in the West today that we might be able to plug into.
Okay, so of course there's a huge number of activities that are going on in the West, and I'm just going to highlight a few here, and you'll see they're a bit Seattle-centric, which we really can't help. And this is sort of arranged in the order of sort of duration of engagement, you might think of it. And so there's, as we've heard about, certainly in the civic tech discussion, there's huge opportunities for these sort of short-term events, which may take place over a single day up to a week. We have some really nice examples of urban science hackathons that have happened in the last year in Seattle, Hack the Commute and Hack Housing. We also see, of course, the proliferation of organizations that are helping to facilitate and organize these types of hackathons that are taking advantage of open government data and arranging and coordinating and facilitating these sorts of hack events. Notably, there was a recent data deep dive on homelessness using Monterey County data, and actually tomorrow, Phil's going to rush out of here for it. Actually starting tonight. DataKind is sponsoring a hackathon on traffic safety up in our data science studio. Just moving a little bit away from urban science, we're also seeing, and we've sponsored through our institute hackathons, and Aria mentioned the upcoming Neural Hack. Astro Hack has happened 2 times, distributed amongst the data science environment institutions, and we're in the process of planning a GeoHack Week. Many opportunities that the Hub can think about organizing these types of hackathons, and as Meredith mentioned, at International Data Week in Denver, we're co-sponsoring a sort of best practices of hackathons event. I already mentioned data science for social good. I'm sort of bringing it up in a different context here, and that we see this as a really nice model for teen science on kind of a short term. Again, this is a 10-week program. It's a really nice opportunity to get the right people in the room and to also provide an opportunity for student training. So we're bringing together the domain experts, the technology and methodology experts, having the stakeholders in the room rather than sort of throwing a project over the fence, having them engaged and involved in the problem solving. Also, again, bringing students in, so providing that opportunity for real life data solving and advancing technical skills. And we also bring into the picture the integration of ethnographers into this team who help regularly give us feedback on the process of how we're doing at creating this type of endeavor. As you can see, I think I won't go into the detail on the projects here. We can talk about that at the break. These are, as Mike Norman listed, these are some of the projects that we've interacted with in terms of bespoke proposals. The list of universities involved is not exhaustive because in many cases these partnerships are already in existence and involved many universities, government organizations, and other agencies. But you can see that the proposals that are already interacting with the hub span quite diverse different types of projects, including public safety, energy efficiency, transportation, sensor implementation, and decision-making tools. And so already there's a lot of activities that have been identified and are already happening within the context of the hub, but I'm really looking forward to this afternoon's breakout session to talk about some of the things that we could specifically do in this urban science space. And we've had a lot of really nice ideas, both at the local and national level of what the government's interested in us doing. And I think we need to think about as a community of what we're interested in doing and what makes us unique in the West and the problems that we can challenge. That we can solve. We have very similar types of cities, and we're likely to be encountering the same types of bottlenecks across these different areas as we try to implement some of the same problems, or tackle some of the same problems, and bring online new solutions that are driven by data innovation. So I look forward to seeing you this afternoon.
We have Sarah Wright and, Steph Wright and Anastasoff. I need lunch soon.
It's all good.
It's like they were
So I'm actually just going to be throwing a lot of questions at everybody, not coming up with answers. That's this job. First thing I want to mention is we all know that science has changed in recent years, and a lot of that is due to technology. Because of technology, but in large part in what it allows us to do. It changes how we collaborate. It changes it has changed how we collect, how we store. I love that image in the middle. I hope y'all can see that. Analyze, that have been built to help us with this. This slide later, it would have some more examples from the things I talked about here today. Challenge is science enabled. Okay, close enough. Too many words. The biggest one really is research outputs, and that's what a lot of people focus on. Even with the examples of tools that I provided in the previous slide, there are still lots of challenges at data, how we collaborate across institutions, across geographic locations, how we collaborate across fields, developing a research output that isn't just the traditional research article. So many more things are involved in that now. We have data, we have the code is considered an output. All this stuff needs to be shared. How do we share it? How do we visualize it? How do we store it? How do we make this stuff available, keeping in mind legal issues, ethical issues, policy issues? And training has already been mentioned a lot, so I won't go into that too much. But some of the questions, how do we train new researchers? How do we train existing researchers so that they acquire the skills that are necessary for teaching? Is it online? Is it in person? Who should do the teaching? Are there other mediums to getting for this? And it's not just, but also about others in the field or others in your lab, but also to the public. Positions? Is it in industry? Is it in education only? How do they get there? How do people know? How do people know about these opportunities? So I mentioned one more thing that I think frequently gets talked about. What does success look like, and how do we measure it? How do we know that we're actually succeeding and addressing these challenges? And with that, I'm going to turn it over to Ed.
Just commercials for breakouts that will begin at 2 o'clock. So hopefully you'll find something that interests you from among all of these. And I'm going to talk to you about an effort that spans the University of Washington, UC Berkeley, and NYU, sponsored by the Moore and Sloan Foundation, the Data Science Environments. The project here is really to try and transform the process of discovery in a bunch of fields at these institutions and to create models for doing it. To be honest, the Moore and Sloan Foundations have zero interest in statistics and computer science and applied mathematics. They care about the social sciences, the physical sciences, and the non-human life sciences. And they're smart enough to realize that new partnerships and new technologies are necessary in order to drive forward discovery in those fields. Is to figure out how to turn universities into places where that kind of discovery flourishes. The picture we use as our motivation, this is from the proposal the 3 universities submitted a couple of years ago. In the middle, many of the challenges that Steph identified, for example, career paths, education and training, areas for sort of collaborative interaction, a set of methodology scientists, all of us have a set of application scientists in physical life and social sciences. And the goal is to create a sort of rapid virtuous cycle in which advances in data science methodologies drive advances in discovery, which motivate new advances in methodology and around you go. So that's the goal. About a small number of the things that we're doing, and this is what I hope we'll all discuss in terms of activities this afternoon. The educational programs, the undergraduate level, the graduate level, groups, and so forth. We have worked very hard at all of our campuses to hire what we call pie-shaped faculty. This is a phrase that I first got from Alex Allais at Johns Hopkins. The idea here is faculty who are strong both in advancing methodologies and in putting those to use in some fields. So at UW, what's happened is the provost has given us a set of half-faculty positions that we can use as sweeteners when departments of astronomy or biology or sociology or economics are potentially interested in hiring such persons. We have a postdoc program and a graduate student program in which these individuals are dual mentored. They have a faculty mentor in an application field, which is typically their major, or in a methodology field. The goal is to produce a new generation of scientists, of discoverers who are strong in both of those areas. At all of our campuses, we have created a shared space. Interestingly, in UW and Berkeley, that space has come from the libraries. Here at Berkeley, is on the main floor of what I'll call the sort of Gothic research library. At UW, it's on the top floor of the physics astronomy building, demonstrating clearly that we are sort of there for scientific advancement as opposed to computer scientific advancement. And these collaboration spaces have been extraordinarily important, and the libraries have been data, information is the business they're in. The question is, what does that look like in So the Collaboratory has been hugely important. Lots of training and mentoring activities, you've heard some of those mentioned already. A lot of partnerships, such as an incubation program, the data science for social good, you've mentioned